Okay, welcome back. So h, you'll notice here it's a trinomial, no common factors, and this is what we would call a complex trinomial because you have an a value here that's not 1. So if you're going to use an array for this one, set up like you would before with your squared term in the top left, your constant in the bottom right, and a couple ways of going about it. And one way involves a little bit of trial and error. So what you want to do here is you want to try something that will multiply to 10x squared. So let's just say I want to try 5x and 2x as a possibility. And then you can try something that multiplies to negative 3. So again, you can try, let's just say negative 3 and 1. And what we're going to do is we're going to try the array and see if it works. So we have 5x times negative 3 gives me negative 15x. Okay, and 2x times 1 gives me 2x. So I put these together, add them together. Oh, I get negative 13x here and add these together, which is not what I have here. So this isn't right. So it might mean you try a different combination here, maybe putting the negative 3 up here, the 1 down here, or a different combination here for instead of 5x and 2x, I could try 10x and 1x. So a little bit of trial and error here. Let me try something else here. I'm going to first try switching the negative 3 and 1 around. So again, let's see what happens when I try negative 3 and 1. So in this case here, I have 5x times 1 gives me 5x. In this case, 2x times negative 3 gives me negative 6x. Okay. When I put these together, I wind up with 5x minus 6x, which is minus 1x, which is exactly what I have up here. So I do wind up having this factored. This winds up being 5x minus 3 and 2x plus 1. Now, for those of you who don't like that trial and error approach, one thing you can do, let's say you wanted to try this one from scratch here. Let's say we didn't know what the final answer was. If you're good at finding pairs of numbers that multiply to one thing and add to the other, like we do with simple trinomials, you can take that approach here. Except the difference is you need to find two numbers that multiply, instead of just multiplying to c, this 3 here, negative 3, sorry, multiplying to negative 3, we need things that multiply to a times c. So in this case, they have to multiply to 10 times negative 3, which is negative 30. So you need to find two numbers that multiply to negative 30 and add to negative 1. Okay, and if you do a quick inspection, you can see those numbers are going to be negative 6 and 5. Okay, and then what you can do with your array is once you have 10x squared and minus 3 in here, you know this minus 6 and 5 are going to make up your x terms. So you're going to get minus 6x and 5x. And then you can use that to reverse engineer what goes on the outside of your array. So knowing here that you have 10x squared, your only real options here are to have 5x and 2x or 10x and 1x. The only way you can get these numbers to work out is if you have 5x here and 2x here. Okay, 5x times what gives me 5x? It's 1, so I get positive 1 here. 2x times what gives me minus 6x, minus 3. And again, I get the same answer in the end. So if you're good at finding pairs of numbers that work here, that's another way you can fill in an array for a complex trinomial. Now, if you never saw arrays before, you might have done a method called decomposition, which would have started by using this approach right here. So again, find two numbers that multiply negative 30, adding to negative 1, and you get negative 6 and 5. And then what you could then do, you could take this equation, this 10x squared minus x minus 3, and then you could rewrite that as 10x squared. We're going to replace the minus x with our two numbers here. So this is going to be minus 6x plus 5x minus 3. And what you then notice, I haven't actually changed anything here. I'm rewriting negative x as negative 6x plus 5x. So really nothing's changed. And then what I would then do here is try and factor this one using grouping. So I would group these two terms together, these two terms together, common factor them, and if I've done everything right, it should group and eventually lead me to the same answer I got over here. So between 10x squared and 6x, those have 2x in common, if I'm not mistaken. And what's left over here, 2x times 5x gives me 10x squared. 2x times minus 3 gives me negative 6x. These don't have anything in common, the 5x and the minus 3, so I'm just going to take out an invisible 1 here, and I'm going to be left with 5x minus 3. Okay? And now you can tell I've grouped these correctly because what I have here is the same. So now my common factor between 2x, 5x minus 3, and 1, 5x minus 3, is that bracket 5x minus 3. So it factors into 5x minus 3. Then what's left over is 2x plus 1. So if you never saw arrays, this is likely how you did factoring last year. Again, whatever method you prefer will work for you. I personally think arrays is a little bit faster, but if you're comfortable with this method, there's nothing wrong with it. Alright, so that gets us through doing a complex trinomial. There's a couple of other different types of examples up here. Again, please try them all on your own first. Pause the video and give them a go. And when you're ready, push play and we'll run through them quickly. Thanks. Okay, first things first, for I look for a common factor first. At the very least, if there's nothing common, you want to take out this negative, but there is more we can take out. Everything here is divisible by 3. So I'm going to take out the negative and the 3. So doing that, I'm going to be left with 4x squared plus 13x minus 12. Okay, so throwing those into the array, the 4x squared and the minus 12. Again, you can do the more trial and error approach where you try different combinations and multiply to 4x squared. So you can try 2x and 2x. If none of those work, you can try 4x and x. And different combinations and multiply to negative 12. Now, in the end, what works here is if you have 4x and x here, and if you try 4 and negative 3 here. So that gives me negative 3x here, 16x here. Again, I know it works because those add to 13x, which is what I have in my original expression here. So I get negative 3, 4x minus 3, and x plus 4. Okay, next one. You're going to need another array for this one. And there's no common factors here, so let's throw in what we know. Let's try a different color. So 6x squared up here, 4y squared down here. And again, it looks a bit more complicated because you have the xy term and the y squared, but you can still treat just like you would a regular complex trinomial. The only thing you're going to watch for here is when you're making your array, you can try different combinations here. The one that winds up working is 3x and 2x. When you're looking here for combinations that multiply to 4y squared, you want to make sure that you have a y here and a y here so that when you multiply, you get the y squared. So what you can have as a possibility here would be, for example, 2y and 2y. Multiplied together, those give you 4y squared. Now, this one actually ends up being the right answer because when you fill this in, you don't get negative 11xy. So I'm just going to undo those ones. And again, you can try different combinations. The one that does work in the end is to give you negative 4y up here and negative y down here. So to confirm, that will give me negative 3xy here and negative 8xy here. Okay, so then I have my factored form. Fun stuff. Okay, a couple more, almost done. So when you tried k, first thing you should have done is, again, taken out a common factor. So all these are divisible by 3. So before you do anything else, do that. Again, looks a bit more complicated because now we have something that's to the power 4. But let's see what happens when you throw it into an array. So we're going to have x to the 4th here, minus 36. So when you're trying to think what multiplies to x to the 4th, there's not a lot of options here. Let's do x squared and x squared. And again, it kind of looks like simple trinomial except with different exponents here. Let's think, what multiplies to negative 36 adds to positive 5? Multiply to negative 36, add to positive 5. And after a little bit of playing around with it, you can see those answers are going to be positive 9 and negative 4. So that means when I fill in my array, I'll get negative 4x squared here 9x squared here. So those middle terms here, those x squareds, add to give you 5x squared. So that gives me a factored form of 3x squared plus 9 and x squared minus 4. And it's very, very tempting to say we're done here, but we have to be a little bit careful. We're actually not fully done yet. So if this is where you stopped, take a quick second, look at it, and see maybe where we could take this a little bit further. And where it comes from is actually from this last factor right here. X squared minus 4, you'll notice it's a perfect square minus another perfect square, so this is a difference of squares. And this part factors down further into x minus 2, x plus 2. Okay, the rest still stays the same. We can't take down x squared plus 9 any further. That's a sum of squares. That does not factor at all. So this is what our final factored form is going to look like. Okay, one last one to look at here. First thing, as always, look for a common factor. Okay, so all these are divisible by 3, and of course we're going to take out the negative as well to make our life easier. So I'll get negative 3. And left over you should have 9x squared minus 30x plus 25. So, as always, throw it into an array. Maybe let's not take that one. Let's grab a fresh one from up here. Okay, so throwing everything in. One thing you may notice here, perfect square, perfect square. So this might be a perfect square trinomial. If I do so, let's try it. I'm going to have 3x and 3x. For 25, do I use a positive 5, negative 5, negative 5? Have to add to a negative here, so this will have to be negative 5 and negative 5 if it's going to work. So that'll give me negative 15x and negative 15x. Which when you put together gives you negative 30x, which is what we need. So this factors into negative 3. I'm going to have 3x minus 5 all squared. Okay, couple last ones to do here. At m, we have 4 terms. When you have 4 terms, to me the first thing I would try is grouping. It seems to be the only thing we can really try right off the bat here. So when you're grouping, group your first 2 terms together, and then you group your second 2 terms together. Common factor each one, see what we get. So between these first 2 terms, these both have x cubed in common. And what's left over is going to be x squared plus 4. Okay, looking at these next 2 terms here between negative 3x and minus 12, they both have a minus 3. What's left over, you're going to get x squared minus 12, factor out negative 3, you get plus 4. So if this is going to group, what you have here in these 2 brackets needs to be the same, because that becomes our next common factor. We're going to take out x squared plus 4. Okay, that should be squared there. And what's left over is x cubed from over here, and minus 3. Okay, you check to see if these can go any further. This isn't a difference of squares because 3 is not a perfect square. That's not a difference of squares because it's addition. So we've taken this as far as we can go. Okay, down here in n, it looks like something that's like this step right here in the previous grouping. However, one slight difference. Here we have x minus 7, here we have 7 minus x. Those are not quite the same, because here the x is positive, here the x is negative. First one, the 7 is negative, here the 7 is positive. We're going to do a little bit of manipulation here to try and get those to be the same. So I'm going to leave this as 3x times x minus 7. Okay, and just rewrite this second bracket as negative x plus 7. And what I'm going to do with this, I'm going to factor the negative 1 out of this bracket right here, absorb it into the 2 out here, then what's left over will be a positive x and a negative 7, so it'll match this. So what that's going to look like here, I'm going to get 3x times x minus 7. Okay, so I just noticed here that my time limit's about to run out, so you'll have to move on to part 3.